In today's video, let's discuss what is a distributive lattice. See here, this topic is related to the discrete mathematics. And coming to the definition, a lattice L less than or equal to is said to be a distributive lattice if and only if it satisfies the following properties. So these are the properties, that is A join B meet C is equal to A join B meet A join C. And the next property is A meet B join C is equal to, this is A meet B join, this is A meet C. So if any lattice satisfies these two properties, then we say that the given lattice is a distributive lattice. And see here, there is an example. Verify whether the lattices given by the hash diagram are distributive. So these are the diagrams related to this. So we have to apply the properties of the distributive law. So if it holds both the properties, then we say that the given lattice is a distributive lattice. And see here, it is a bounded lattice. So 0 is the least element and 1 is the greatest element. And here also 0 is the least and 1 is the greatest element. So this is the hash diagram for the examples. And see here, L is said to be distributive lattice if and only if it satisfies these two properties. So we have to check whether it satisfies the given properties. And see, coming to the first question here, the given hash diagram is shown here. So the first distributive lattice is A join B meet C is equal to A join B meet A join C. First of all, I am taking the elements from the given lattice. So here the lattice L1 contains, so the least element 1, this is A1, B1, C1, and again the greatest element 1. So it is a bounded lattice. And next one, so if I consider 3 elements from this set, finite set, that is A1, B1, C1 belongs to the lattice L1, then we have to apply this distributive law. In place of A, I can write A1, in place of B, I have to write B1, and in place of C as C1. See here, let's see what happens. That is A1 join, this is B1 meet C1 is equal to, this is A1 join B1 meet, this is A1 join C1. From the hash diagram, see, this is A1 join B1 meet C1. So this is B1 meet C1. So B1 meet C1 is nothing but the greatest lower bound. So the lower bound here is a C1. And the next one, A1 join B1. So this is A1 join B1. So join is nothing but the least upper bound. So the least upper bound here is 1. So for A1 B1, the least upper bound is here 1. This is again meet. And next one, A1 join C1. This is A1 join C1. So join A1 join C1 is nothing but the least upper bound. So the upper bound of these two. So they meet at the same point 1 here. So this is again 1. So A1 join C1. So this is A1 and this is C1. Join least upper bound. We have to go up. So this is the meeting point here, upper bound. So 1. Here also, if you observe, 1 meet 1. So among 1 and 1, 1 is the least element. So it satisfies the distributive law. Therefore A join, this is B meet C is equal to, this is A join B meet, this is A join C. So equation 1 holds. And the next one, coming to the second distributive law, again I am taking 3 elements, that is A1, B1, C1 belongs to the lattice L1. See here, here is an hash diagram. So this is the hash diagram. So according to the hash diagram, this is 1, this is A1, this is B1, this is C1, and again this is 1. So this value is 1. So coming to this question, so again we have to apply. This is A1 meet B1 join C1 is equal to, this is A1 join B1 meet, this is A1 join C1. So again A1, this is meet B1 join C1. So B1 join C1. Among these two, the least upper bound here is B1. So this is B1 is equal to A1 join B1. So this is A1 and this is B1. Among these two, the least upper bound, they meet at a point 1. Meet A1 joins C1. So this is A1 and this is C1. So join least upper bound. So again they meet at a point 1. And next one, A1 meet B1. So A1 and B1. So meet greatest lower bound. So the lower bound of these two is nothing but 0. So here among 1 and 1. So 1 is the, here meet. Meet is nothing but the greatest lower bound. So lower bound is nothing but 0. So 0 never equals 1. Therefore, we say that the second distributive law, that is A meet B join C, is not equal to, that is A join B meet A join C. See here, from this property the distributive law doesn't hold. Therefore, we say that, therefore the given lattice, the lattice given is not distributive. Therefore, the lattice given is not a distributive lattice. It is not a distributive lattice. See here, so both the properties should hold. So the first property holds and the second property fails. Therefore, we say that the given lattice here, according to this hash diagram, it is not a distributive lattice. And coming to the second hash diagram here, the hash diagram here is like this. So 0 is the least element and 1 is the greatest element, and we have to check whether the given lattice is a distributive lattice or not. So here is the hash diagram and we have to find out the distributive laws. So again I am taking 3 elements. So here lattice L1 contains, as it is a finite set, the least element here is 1. The next one, this is A2, B2, C2 and again 1. So this is A2, B2, C2 and 1. So these are the elements. Among these elements, I have chosen 3 elements. Let A2, B2, C2 belongs to the lattice 2. So now I have to apply here. So if I apply in place of A, A2, in place of B, B2, in place of C, C2. So let's get started. That is A2 join, this is B2 meet C2 is equal to, here also, this is A2 join B2 meet, this is A2 join C2. And see here the diagram is very clear according to the hash diagram. So we have A2 join B2 meet C2. So this is B2 meet C2. So meeting is nothing but the greatest lower bound among these two is 0. So this is 0 and here A2 join B2. So A2 join B2. Join is nothing but 1. So here 1 meet. A2 join C2. This is A2 join C2. So here they meet at a point 1. And next coming to A2 join 0. So A2 join 0. So join is nothing but the least upper bound. The upper bound among A2 and 0 is A2. So this is A2 and here 1 meet 1. So 1 meet 1. Among 1 and 1, 1 is the greatest lower bound here. So 1. So A2 doesn't not equal to 1. Therefore, we say that is A join B meet C not equal to, this is A join B meet, this is A join C. And coming to the second property here, let, this is A2, B2, C2 belongs to the set L2 and let's find out what happens. So this is A2 meet, this is B2 join C2 is equal to, again this is A2 join, this is B2 meet, this is A2 join C2. So in place of A, I wrote A2, in place of B as B2 and in place of C as C2. And here is the hash diagram. So this is the hash diagram. So according to this, so we have here the greatest element 1, it is the least element, this is A2 and this is B2 and this is a C2. So we have to verify this one. So for verification, see what happens. This is A2 already. Meet B2 join C2. So B2 join C2. So join is nothing but the least upper bound here is 1 here. And next A2 join B2. So this is A2 join B2. So here the least upper bound here is 1 meet, and here A2 join C2. So this is A2 and this is C2. They join at a point 1. So here A2 meet 1. So this is A2 meet 1. Among these two, See here, the greatest lower bound here is A2 and among 1 meet 1. So 1 meet 1 is nothing but here 1 meet 1. The lower bound here is again 1. So this is not verified. So this is not verified. Hence we say that therefore this is A meet B join C is not equal to A join B meet this is A join C. Hence therefore the given lattice, therefore the lattice given is not a distributive lattice. It is not a distributive lattice. So this is how we have to check the laws, and this is so simple. There are two operations here, that is join and meet. So join is nothing but the least upper bound and meet is nothing but the greatest lower bound. So here is the hash diagram. Using the hash diagram, so we can easily check whether the distributive laws holds or not. And here in this case both the properties fails, and therefore we say that the lattice given is not a distributive lattice. And thank you so much for watching and staying till the end. And really, if you like this video, please pass it on to your friends, and hopefully you can do any kind of problem. Thank you so much, and please subscribe, leave a comment below and share it with your friends.